Hello everyone, welcome to this tutorial. So today we are going to talk about torsion, and torsion can be defined as twisting moments, and I can use this as an example. If you have a bearing at some point that is connected to a shaft, and we are going to have some torsion, or rather twisting moments. Twisting moments are as a result of two unequal torques. So for example, the bearing will have, let's say, an anti-clockwise torque, and the shaft will have a clockwise torque. So in such a case, the shaft will experience what we call torsion, that is twisting moment. Now, because of, so we've already talked about the unequal concept of torque that brings about the twisting of the shaft. So we can also say that torsion is torque. Okay. Now mathematically we know that for us to get torque, we need to find the tangential force. Okay. This in this case being Ft and multiplied by the radius of from the center. So I'll use this diagram here. So if we have a rotating member and it has radius r, and you apply a tangential force which is equivalent to Ft at this point, then it means that this member here will experience what we term as torque. Now to get that, you'll have to get the magnitude of the tangential force and multiply it by the radius of the center of this rotating member. So that is simply how we can work out torque, and therefore torque can relate easily with torsion. In our next segment, we want to look at what is the torsional equation and define some of the terms that they entails torsional equation. So I'll write it down in a few. So torsional equation is given by T over J equivalent to Fs over R is equal to G theta over L. Now in some cases, Fs is replaced by tau to mean maximum shear stress. Okay. Now we want to define each and every term here. So we are going to write here where T is equivalent to, so what is the equivalence of T? T is torque, or what we call twisting moment. Okay. Now this is measured in Newton millimeters. So these have taken just the smallest unit of the length. Or we can talk of Newton. So it should not be per, but Newton meters, centimeters, and so on and so forth. The next term that we're talking about is J, and J is the polar, we call it polar moment of inertia. And basically it is measured in millimeters raised to power 4. So I've just taken the smallest unit in this case. The other term, is tau. Now this is shear stress. Okay, so shear stress is measured in Newton per millimeter squared, or Newton per meter squared, and so on and so forth. We also have another term which is R. Now R is the radius of the shaft. Radius of the shaft. So this is usually measured in meters or millimeters. Okay. Then in this same equation, we also have another term, G. So G is defined as modulus of rigidity. Okay. Now, modulus of rigidity is also another term in this equation. It is measured in Newton per square millimeter, just as stress here. Okay. Then we have theta, which is in this case angle of twist. Okay. And angle of twist is measured in radians. Okay. So later on, we're going to look at how we can convert radians to degrees. So say degrees, okay. And apart from that, we also have another term here, L. So L stands for, so let me write that down. L stands for length of the shaft. Okay. Now the length of the shaft can be measured in millimeters or meters, and so on and so forth. So basically, this is the torsional equation, and in our next tutorial, we are going to see how to derive the torsional equation.